All right. I don't care if you do substitution. If you do something different than I did, that's fine. If you do elimination or substitution, whichever one you prefer to do. When you have two lines, there's no squares in here. You can do y equals y equals. You can substitute y into the other one, solve for y. That's my choice over here. You could do elimination, multiply this by 2, do elimination. You'll still come out with the same answer, as long as you didn't make a mistake. So it's a good idea to check your answer into something that we didn't change. If we use this one, check it into this one. A -2 and 2 gives me 0. Just do a spot check, and you'll be fine. Do the one that you didn't manipulate. And stop me if you have any questions. If you did it a different way, I'll be glad to do it your way, if it didn't work out. This one, I was going to solve for y. Whether you add y on this side, then add 4, you're going to get the same thing, whichever way you decide to do. Or if you could solve for y, substitute in, do that. Set them up so that you line up. I did this elimination, but you can absolutely just do what I said. Solve this for y, solve this for y, set them equal to each other. There's a number of ways. What I don't like to do on elimination is to do the subtract. I like to multiply everything by -1. Because I find on the subtract, somebody always misses a sign. So I just multiply by -1. If I wanted to change this sign, so I multiplied by -1 rather than subtract it. A lot of teachers teach this. They subtract, and then they go in and change all the signs. What I find is either you write over what you had and you forget if you did or not, or you forget a sign. So I just multiply by -1 and I add them. Out comes my y's. I factor, move this to one side. Whenever you have x squared and x, factor, set them equal to 0. Remember, you also need a y to go with your x. Anybody do this differently that it didn't work out? Okay, see if you spot whatever you did. You should come down to this point here and then be able to solve from there.
I think I tried, I set them equal to each other.
Okay, but using your y's?
Yeah, y. It's -y equals -4 minus x.
-4 minus x.
And then -x squared minus 2.
Okay, so you're assuming these are the same, so we should be able to set these equal to each other. Okay, let's pull everything to one side. So we got an x squared minus an x minus 2. And you'd be right there. You're okay? Okay, you can absolutely do that. Did you see what Allie did that time? Instead of getting y, if she got them both to -y, negative y's have to be equal to each other too. So she set them both equal to each other. Okay, let's strip up again. I put it up again. No, that's no problem. I'm glad to go backwards. Okay. All right. Guys, stay with this. You're welcome, honey. Okay, next one. I substituted this y into this y. This is a line. This is a cubing function that does this, right? It has the down and the up thing. So it could pass it a number of times. It could pass, because you're doing this, your line could technically pass through 3 times. Once, none, maybe not none, but 1. It depends on where your line goes, or up to 3 times. So now, I substituted in. Do I need the parentheses? No, I just put the parentheses there because it was an add, but I put it there to show you there's my substitution. This piece in for this, for the y. I collected my like terms. You're on one side of the equal side. Erin, stay with me. Collect your like terms. Factor out an x. Okay? You cannot divide by x. Factor out an x, and yeah, this guy's a little strange looking. Take the square root, you get a plus or minus. X is 0, not bad. You already have a y equals. Bring this guy down and find its corresponding y. So I plug in my plug in my x of 0, and I get y is 2. There is one of my points. Now, you do the same thing here. You plug it in twice, one for your positive radical 3, one for your negative radical 3. When you do that, you cannot get rid of your radical 3. It's going to stay with you. You're basically doing this. Negative 3 times radical 3 plus 2, and negative 3 times negative radical 3 plus 2. This is just going to become a positive in 1. You have to leave it like that. You cannot combine these. And this guy will just stay a negative for this guy. Now, you found your y's, just hook it up with your x. Every point is an xy. So if this is your x plus or minus radical 3, it corresponds to whichever one you put in. So radical 3 and then this guy. This is actually your y. And do the same for the other one. Just to show you that they don't all have to come out to be nice numbers. Yes. The negative for which one? Right here. I separated it into 2. I actually just did the positive here and then the negative. One right next to the other.
The negative on like the 3 on the outside.
Yeah, that stays. That's always there. The negative 3 times a positive gives me a negative. The negative 3 times a negative gives me a positive. Yeah. Yes. Oh, I don't know. I didn't make the test yet, but I'll try not to make it look that bad. Okay? I'll try not to. But guys, the process is the same. You're just plugging it in. Yeah, the process is the same. Okay? All right, let's see what else we got here. This guy better? You have a line and a parabola. A line can cross a parabola twice, once, or no times. So I substituted, but be careful, you have a negative sign here. And this was only one term, so we were lucky. So I plugged it in, and you've got a quadratic factor. It factors into x minus 1 times x minus 1. 2 of the same factors, so you only have to do it once. Yes?
How do you know how much to like do the adding thing and then do like the substitution?
To do, like, what adding thing? I don't want any noise. This guy is a circle and a line. You can cross twice, once to be tangent, or none. Now, when you have x squared, if you're going to get it x or y by itself, you're going to get a radical plus or minus. That I wouldn't do. So I would look to this one, and I would solve for whatever one is easier, which is y, right? Solve in terms of y, and then where I see my y, I'm just going to substitute this piece in here. Now, I showed you this one yesterday on your homework. When you substitute that in, you still have a square. You have to FOIL this guy. This is 10 minus 2x times 10 minus 2x. There is no 100 minus 4x squared. Raised to the power only works on one term, not two terms. So you have to FOIL this guy. So this stays. So I FOIL this into this. 100 minus 20 is minus 40x plus 4x squared. Collect your like terms of your x squares, bring your 25 over, and when you get to this point, if you can divide by a common factor to get a is equal to 1, do that. And of course, this one was divisible by 5. So now we can break this down, and it's much easier to factor.
Can you scroll down?
Yep, I just have to erase my A's. Okay? Remember I kind of helped you set this one up yesterday in class because I knew this was going to be a tougher one. Whenever you have an x squared, don't solve for x, because when you take the square root, you get two equations. That's a nightmare to substitute it into twice two equations. Yes, Aaron?
Oh, I didn't do it like that though. And I got 0.
You got the same answers?
Yeah, but I also substituted for y too though.
Okay, what'd you do?
For the first problem, I solved the x plus y squared, and I solved for y, but instead of just putting,
Okay, so you solved for y. You got y squared. That's why you only got one answer. And then what'd you do? Take the square root?
yeah, square root.
Right, but remember you get a plus and minus. So you only substituted in one of those, so you got one answer. You got to do it again with the negative one. To get, that's what I said, when you take the square root, you get a plus and minus. That's a little bit harder to deal with a square. Question? Yes. And that's not a bad deal to plug this in for y. However, you got a radical, you're going to have to get everything to one side and square it to get rid of your radical. It's the long way around. And then you got to do it twice. But see, that's a problem with y equals y. When you set this up, you got this. You got y equals the square root of 25 minus x squared, plus or minus. You actually have two equations.
So do you make it a negative?
You got to do it twice. No. No. Now the problem with that is this. Once you plug that in here, you move it to the other side, you squared it anyway, didn't you? You did exactly what we did down here. You squared this anyway. But you got to do it twice though, not once. Once for the positive, once for the negative, or you're only going to get one solution. Yes. You got y equal y, right? Set your y's equal to each other. Easiest way. You've already solved for y. This is a substitution. Set them equal to each other. Get everything to one side. You have descending x's. Never divide by a variable. Once you reach here, factor. So now you've got your factors. And you have your y set up. I would just use that one to find my answers. It's already set up y equals. You know that don't reinvent the wheel. Use whatever's there, whichever is easiest. Good? This was a good exercise in getting back to your algebra skills as well. Did you do this one too? This is the last one?
I didn't do that one. Oh, I take it up to the 1 over x thing. I just didn't get it.
Yeah. That's actually a hyperbola, which we'll be doing pretty soon is your hyperbolas. That's the varies inversely thing when you do the product of something. Remember your problems in algebra 2, something varies inversely. So you do x times y is a constant. That's your the hyperbolas that come out of this. Yeah, it was a little bit difficult to look at y equals as a fraction, but we can certainly work with it. Remember, these are 3 terms, and a fourth over here. Multiply everybody by your denominator, by x. And then you had a nice little thing. Just reorder this and factor it. So Donovan, I won't put that one on the test either. Okay, I won't put that one on the test either. Alright? We're going to back substitute. Place z into that. Shh. This is called back substitution. When you can go backwards. Replace the z. God bless you. Then you'll find y. Then you replace the z and the y, and you'll find x. It's back substitution. You start with the last one, z. You substitute the z into this, you'll get the y. You substitute the y in the z, you'll get the x. So let's label, guys, let's label your equations. This is what I told you, keep your work organized. So let's work with equations 2 and 3. So we're going to put z into 2. So we're going to start like this. and we're going to use this one. We're going to put your z into this equation right here. You need to keep your work as organized as possible. So we're going to subtract 6, and y is -1. And it's a good idea to make a box and put your answers one at a time as you get them. So we know what z is. Now we know what y is. Now, we know our z and our y. We can backtrack into 1 and 2. So you know your z is 2. You know your y is -1. So here's your equation that uses all 3, because now we can eliminate your x, your y and your z to find x. So we plug it in. Here's your y. That was -1. Here's your z. That was 2. Now be careful with your algebra skills. A negative times a negative is a positive. Plus 6. Add these together. Subtract. And x is equal to 1. Okay? Now, when you give me the answer, you can do it like this, or you know how you wrote your ordered pair x, y? We're still going to make an ordered triple here, and we're going to put them in alphabet, the way they appear, alphabetical order. 1, -1, 2. You know how you did your XY pair? Well, this is an XYZ triple. So we're going to still do it like that, or give me your box of information.
Is this going to be in the test?
Yeah, but let's go one step at a time. It won't be so bad. See, I told you math was fun.
Oh, no.
Okay? Good with that? Okay. Here comes a tougher one. Okay, now, z was not in that equation. Now, label your equations 1, 2, and 3. This is our goal. Our goal is to do this. We're going to combine, we're going to have to do it this way. Listen carefully. Combine 2 equations to eliminate 1 variable. Then you're going to combine 2 others to eliminate the same variable. You're going to be left with 2 equations. Then you're going to combine those to eliminate another variable. And then you're going to back substitute. So let's look at this, guys. This has no z. If we combine, like Vanessa says, 1 and 3, what should we eliminate? The z. So for 1 and 3, we're going to eliminate the z. So write down like this. And you know how to do these. Now, it may look nicer to eliminate something else, but we got to eliminate the z. So what should I multiply the first equation by? I need these to be the same multiple but opposite signs. 5. So we're going to come over here and multiply every term by 5. Every term, including the opposite, the equal sign. What should we multiply the second one by? 3. But if I make 3, I'll get a positive 15. -3. So watch that negative sign as you multiply across. A negative times a negative is a positive. Now, we're going to combine these. So this is going to give me -x plus 5y, there goes my z's, is -6. Label this A. Well, this is how I do it, and ever since I was in high school, I label my original equations 1, 2, 3. When I combine them, I label them A's and B's. This way I know what I have to work with in the next step. Now, normally, if this had a z, we could combine this one and eliminate z. And then combine those two. But this one has no z. So now our second step is to work with equation 2 and my A. So now we have no Z in here. So let's just put this together. Here's one of them. I line up this guy right underneath it. And I want to eliminate another variable now. Z is gone. What could I eliminate? I could do the Y. Would be easier, X. So how would I, they're both, because they're both ones. So you're multiplied by a negative 1. Now, some people say just subtract, which is fine, but you got to go change the signs anyway. So we keep the top one. We change all the signs. Plus, minus, plus. We eliminate the X. We divide by negative 2. And we get Y is equal to negative 1. Okay, so now, we go here. So Y is negative 1. Now, we're going to substitute this back into one of these equations and find another variable. You have two choices. You could substitute it back into one of these, either one of these. Me, I would pick this one, only because that one is one of the original ones, right? We kind of changed equation 2, and most of the time you have no choice. You bring it back into the one that you changed. So we're going to take this guy for our third step, and we're going to put this back into this one, into equation 2. We know that Y is negative 1, so we're going to substitute it back in. Now watch, be careful with your signs. Negative X minus 3 is negative 4. You're going to add 3 to both sides. And how do I solve for X? Divide by negative 1. So X is going to be equal to 1. Yeah. And now our last step, I'm sorry I ran out of room. I'm just going to put it up here. I can't move my screen because then I'll lose my work. I'll just put it up here. The next step is to find C. Pick any of those equations that have a Z in it. So which one should I pick?
Maybe the first one.
Okay, let's go with the first one. So I plug in my X, plug in my Y, I'm going to locate Z. So this gives me 1, a negative times a negative is a positive 2. This gives me 3 plus 3Z equals 9. I subtract 3. 3Z equals 6. And Z is equal to 2. Now, what happens sometimes is, if I didn't manipulate this last one, I can put all 3 of them into here, and that's my check. Whichever one you didn't manipulate at all, use that for your check. Don't use one of these that you changed, because you already changed those. Now, sometimes what happens is there's a Z here. Just give me 1 second. There might be an E here. So you have to take 2, and then take 2 different ones, and work those so that you eliminate the same variable. Okay, that might happen next. I was hoping to get to one, but try the homework and see how far you get with your homework. Try it. A lot of kids like to algebra. There's nothing else but algebra in it.